So, in terms of introductions, my name's Jack Dudman. I'm a member of the committee for SIREM Northwestern and North Wales branch. We're joined today by Bill Roberts, the co-founder of Swirrl, a company focused on helping many areas of UK government, making data work best for them. One such area is DEFRA and the Environment Agency, and it is with the help of examples of this work that Bill will discuss with us today the great potential of linking up data. So with that, I will hand over to our speaker, Bill.
Hi, Jack. Thank you very much for that. Let me just swap presentations to get to the right one. Thank you very much, everyone, for coming along today to listen. I hope that I've got something of interest or relevance for you. Yeah, so thanks, Jack. I'm Bill Roberts from a small company called Swirrl. And as Jack was saying, we work mostly with UK government organisations around helping them to manage and share data. So data of all sorts, generally openly licensed, publicly accessible data. Often that's things like statistics or observations or reference data. And yeah, one of the important areas that we work in is on environmental data. And in the talk today, I'll draw quite a few examples from work that we've done with DEFRA and in particular the Environment Agency. So the title of my talk, Linking Up Environmental Data. I'll talk about firstly why you might want to do that. So what's the point and what benefits are we trying to get? Then I'll go on to a little bit of what does it mean in practice. So what do we actually do to try to enable linking up environmental data? I'll use a few examples from work that we've done and from other people's work, and I'll finish with a little bit on what do you actually do if you want to make your data more linkable, or if you want to exploit connections between data that might have been created by others. And the basis of it is very simple, really. That all the important problems that people are trying to solve, particularly in a government or a public sector or kind of environmental scale, need lots of different data to give you a full picture of what's going on. So that's obviously no surprise to anyone. And if you think of what might be the big challenges for us, and of course the standout one is how do we deal with climate change? Then all of those kind of things need a lot of different data sources to give you the information you need. But climate change isn't the only one, of course. How you deal with the COVID pandemic is obviously something that's been in everybody's mind most of the time for the last year or so. But other big ongoing problems of perhaps changing demographics as people live longer, but don't necessarily have more healthy life. How do you deal with that? The changing world of work. And of course, how do we deal with limited environmental resources in a highly populated world? How do we balance the needs of the environment and people's health and the economy? So any of these things are extremely complex problems, and your only hope of making any progress on them is to be able to pull data together from lots of different places. So that happens at that massive scale of how do we try to tackle climate change, but also at many smaller scale things that are perhaps more kind of day-to-day type challenges, but nonetheless still need a lot of information to tackle them. So I spent about 20 seconds thinking of what kind of things might the government be thinking about if they're trying to put together some kind of policy response to climate change. And you can quickly rattle off a whole bunch of things. I'm sure there are many more. But one thing to note from this is that they're very wide-ranging, and the kinds of organisations that will produce these are quite diverse. So some of them are going to be government, some of them are going to be I guess independent public bodies. Some of them will be academic researchers or businesses. And even within one sector, if you like, then the groups that are involved in, say, climate modelling or measuring meteorological data are very different from the people that might be looking at transport or industrial activity. So you can quickly see that there's a lot of things that need to be connected together. And all of the most challenging policy areas are like this. So there's a question of what do we do to try to make this more practical? And one thing that I think is important in terms of a kind of changing mindset around this is that I think we need to start thinking of data as infrastructure rather than as a side effect of some application or project. And I've stolen this analogy from Jenny Tennyson at the Open Data Institute because I think it works quite well. That she made an analogy of data, thinking of it as infrastructure with the road network. Because I think a couple of years ago, a lot of people were talking about data is the new oil, in the sense that a lot of companies were springing up trying to exploit opportunities around gathering and analyzing data to produce various kinds of monetizable services. But data isn't like oil in that you don't use it up if you make use of it. So it's something that can be used again and again by lots of different people. So it works a bit better with the analogy of a road network. It helps you get somewhere. We want data to help us navigate to a decision. It's important to design it with longevity in mind and think about it being reused by lots of different people. You want to be able to use your road to get to different destinations, not just a single link between two towns. You need to invest in it. It needs some regulation, it needs standards, and make sure that people are using it appropriately. And I think what certainly I've been trying to argue for a long time, and I'm and alongside many others, is that this needs a bit of a change in mindset in information management in government and elsewhere, to think of the data as the most important bit rather than an application or a project. And one of the things that we're trying to do is to, I guess, use data to create value of some sort. So value in a not just a strictly economic sense, but in a general, do something useful with it. And there was a good report a year or two back from the Bennett Institute at Cambridge University, together with the Open Data Institute, on trying to analyze what kind of things contribute to the value of data. So it was written by economists, so that it comes up with lots of kind of economics style terminology and analysis. But one of the things that I picked out from that when I read it was the economists have this thing that they call externalities, and in particular, positive externalities are things that other people do that make the thing that you have more valuable. And the thing about data is that there's a kind of network effect that that the value builds as the overall corpus of interoperable data builds, and you can make one set of data more valuable by producing other things that support it. So spatial reference data is a good example of that you can do some quite simple things like have a lookup from postcodes to local authorities or to catchments or whatever, that increase the value of data that's expressed about local authorities, because people who don't easily know or want to process these things at large scale can use some kind of lookup from postcodes, so that if they're dealing with things at an address level, then you can quickly look that up to find out which local authority or which catchment or whatever that you're in. And of course, there are many more complex examples of that, but you might think of pulling in pre-existing data about population or housing and combining that with flood risk assessments to let you estimate the impact of a flood if it happened in that place. So that kind of thing of, if you've got two separate data sets but you combine them together, then you can start to do things that were impossible before. And another aspect of that creating value is that it's something that generally involves many people with different roles. And so one of the things that's, I guess, has been blocking doing this effectively at scale is that it's often one person ends up trying to do all the stages in this process. But as we start to do this more, we want to get to something that's more like a kind of industrial supply chain, if you like. And this diagram here is something put together in a report from the European Data Portal a few years ago, just thinking of what are the steps in creating value from data. And one thing that's worth thinking about here is that different organizations can be responsible for different steps of this process. And in order to make that work smoothly, then you need to be able to exchange data and data analysis artifacts effectively between the different steps in this chain. So it's another area where effective interoperability of data is something that enables more value to be created. This is something from a report a few years ago about what data scientists actually do. And this was a survey of asking what's the thing that's most time consuming for data scientists. And by far, the most of them said that the thing that they do most of is cleaning and organizing data. And I think anyone who's worked in any kind of data analysis will be familiar with this, that a big task is getting hold of the data that you want. So maybe finding that it exists or getting it from the organization that produced it. But then what you had is often a big mess of things in different formats and produced for different purposes. And you're trying to pull things out of that to get the information that you want. So one of the things that we're trying to do by linking up environmental data is to get it into a form where it's more ready for analysis, because a bit of upfront investment by the organization that's responsible for producing the data, it has to be done once, but it can be done by the people that know the data best. And then there might be 100 different people that are going to use that for something, and you've saved each of them a lot of time, and you've made their work more reliable by getting the data into good shape. In the 90s, I used to work for an organization doing computational models of coastal waters and estuaries and rivers and stuff. And we used to spend hours hand digitizing paper charts to get the geometry that we could feed into the computational model. I wouldn't be surprised if people still do that sometimes, but I really hope that they don't. And I mean, that's I guess a good simple example of getting your data analysis ready, that if you can share the data in some kind of standardized digital format for the geometry and bathymetry of your area, then you're going to save some poor soul sitting for 2 days in front of a digitizing table with these Admiralty charts with blue tack. So one of the things that we want to do is, by going beyond just simply making the information available, is to think about how it might be reused by others outside of its initial context. And bearing in mind, of course, that a lot of data is valuable in a lot of different contexts. So one other kind of, I guess, preamble kind of thing is that it's not just in public sector that people are obviously realizing this is important. There's quite a big movement in the scientific research community around this, and some of you may have come across these so-called FAIR principles, where FAIR stands for findable, accessible, interoperable, and reusable. If you haven't seen this paper, it's worth a quick read. We'll be sharing, I think Vara's sharing some links as we go along, and I've attached all the links to things I talk about at the end of the slides if anyone wants to look some things up afterwards. But it's a good way to think of the necessary steps to getting value from your data. You've got to be able to find it. You've got to be able to get it in a form that you can use it. You want it to be interoperable so you can use it with other things, and you want to be able to reuse it in different contexts. And that's the essence of what we're trying to achieve. So that's what we want to do. What does it actually mean in practice to link up data? So as we were saying earlier on, we want to be able to combine data from different sources to pull together to analyze a particular problem. And most of it is most of the solution to making this easier is use of standards. But you've got standards for everything. And I think in this context, the most important kinds of standards are having standard reusable identifiers for things, for having data models that describe the structure or schema and meaning of the data that you're sharing, and to have common formats for sharing data. And I think the order of importance is pretty much as I've written it there. having common identifiers for things, giving people giving a thing the same name if two different people are talking about it is the essence of joining up two different data sets. If you pull together two different things and they have, say, a completely different set of codes for geographical areas, then you have to find some kind of lookup that lets you join them together. If everyone's using the same code for the same thing, then you'd be able to do that very easily. Data models are important, especially if you want to try and do some automated processing of the data. And of course, some formats are more common and easier to use than others, but I think that's probably less important because as long as any format for data interchange is documented and is possible to process in software, then you can probably find some easy enough way to convert from one to another to suit what you need. But starting from that question of identifiers, the basis of the approach that we take to a lot of this is something called linked data. And this is a thing that Tim Berners-Lee came up with about 15 years ago. And it's in essence about using the architecture of the web as the way for sharing data. And of course, we use the web all the time just for moving files around, but this is more about using it, I guess the kind of underlying architecture of the thing that powers web browsers, that things have a URL. So here URI stands for uniform resource identifier, but it's actually the same as a URL. And the idea is that the mechanism of the web is all about requesting a URL and getting back some response in a standard form. And the core of the linked data idea is that as well as using a URL for the name of a web page, you can use it to identify anything. So that could be your real world things like places or people or events, or it can be some kind of conceptual thing, but you can give an identifier to anything and you can give it a URL. So the core of the linked data approach is using HTTP URLs, so the same thing that you use in a web page. And that lets you, as well as having just an arbitrary unique identifier for your thing, you can use the mechanisms of the web to look up information about that identifier. So if you look it up, whether that's by putting it in your browser or making a call through some kind of software, then you should give back some standard information about it. And you should think about how you link to other things so that if you have information on one thing, then you can see how you can connect it to others. And this is the essence of the linked data approach, and that's what we do with as the basis of trying to make environmental data more interoperable. And the key starting point for this is the identifier part. And one of the reasons that using the URL URI approach for identifiers is useful is that it builds on that whole web domain infrastructure, with the principle that if you are the owner of some domain, then you can take responsibility for everything that's published at that domain. And so if you want to invent an identifier for something that you're responsible for, then you can invent it in your own web domain, and then you can enable the infrastructure to let people look that up and provide information about it. So this is something that the Government Digital Service has taken on board, and it's they have a kind of recommended open standards for government catalog, if you like. And this is using this approach for identifiers is one of the things that is in that set of standards. So what does that mean in practice? Here's an example of an identifier from the Environment Agency's flood defense asset system. So there's an internal system that they have to manage this kind of information, and the last bit of this URL, the number at the end, is a code number that's used inside that system to identify stuff. But if you're only given 394963, then you don't have any context. It doesn't really mean anything to you. And so by making this into a URL, obviously in itself, it doesn't have any meaning. It's just a string of characters. But if you look it up, then you get a web page about it. And this is the example web page for this particular flood defense asset. And the standards say that as well as providing a web page, you can also provide this in a whole bunch of other formats like XML or JSON and some others. So if you want to do some processing of this in your software, then you can ask for it in a format that's easy for you to process. So this is, if you like, the kind of basic reference information, but of course you can do other things with that and build them into more interesting ways of exploring it. And so this is an application that we manage for the Environment Agency that lets you find and view information about these flood defense assets. And so this particular example is a stretch of embankment somewhere near Warrington, just on the banks of the Mersey. So that's a kind of, I guess, a kind of typical example is that we've got something that could be of interest to people, a specific stretch of flood defense, and we want to be able to describe that and make it easy for you to find it. So that's one example. If you're interested, there's a whole selection of similar applications available as part of the DEFRA Data Services platform. And the link to that will be in the slides and perhaps shared in the chat. So the next thing I mentioned as important for data connecting, for linking up data, is to have an understanding of how the data is structured. And so you know, a data model, sometimes called a schema, it's a way of describing the kinds of things that appear in the data and what properties they have and how they relate to each other. And generally, whenever anyone who's been involved in building a database or some kind of software system will have been aware of this, that you need to work out what your data is going to be and how all the different things in it will interrelate. And the most important thing is that it's a good representation of the data that you have. But this is also an area where there are useful standards. And by starting with looking at what standards are around, there's two benefits. One is that you might save yourself a lot of work because someone will already have done the analysis of the kind of data that you're working with. And the second benefit is that if you're able to use or perhaps extend a standardized data model for this data structure, then it makes it that much easier to interconnect that data with other people's data that follows the same data model. So there's probably, you can have data models for everything, but I think the things that we encounter quite a lot in environmental data are, I guess I picked three things as probably the most important. One is observation data, so measurements of stuff somewhere. One is statistical data. I guess often that is also based on measurements or surveys or administrative information, but generally that involves aggregating the data together and giving you some kind of summary or aggregated statistic about it, like the number of people that live in an area or the average length of fish in your surveys or whatever. And the third one is information about, I guess, management plans and strategies. So a lot of the work that we're involved with in the Environment Agency is looking at different kinds of action plan. So whether that's looking at plans to invest in flood defense infrastructure, or if it's river basin management plans about improving the ecological and chemical health of water bodies, or shoreline management plans around coastal flood defense. There's all kinds of different activities going on, and if you want to get a good overall picture of what's happening in some particular location, then it would be very interesting to be able to see all of these different kinds of activities in one place. And so data models that help with standardizing how we do that are of interest. So we'll just run through some of the examples that we worked with. So one for observations is this standard that was put together as a joint effort of the Open Geospatial Consortium and the World Wide Web Consortium, with the snappy title, Semantic Sensor Network Ontology. If any of you come across things like the OGC Observations and Measurements Standard or Water ML, it's very similar in a lot of ways to those and pulls in a lot of that work into it, but expresses it in a way that's compatible with this linked data approach. So we've been using that, for example, in a recent bit of work on producing an API for accessing ecology and fish data. So the ecology is typically measurements of invertebrates or plants in rivers, and fish is obviously kind of counts of fish species in different places. For the statistical data, we do a lot of work with the RDF data cube vocabulary. This is another W3C standard. And this one is specifically around about statistics. A lot of work on this has been to do with government official statistics. So from DEFRA, but a lot from Office for National Statistics or Ministry of Housing, the Scottish Government as well. And so if you are looking for data that is part of that government stats corpus of information, then this is a very good way to represent that. And again, it's compatible with this linked data view of the world. And finally, for the integrating action plan and management plan work, then we've been looking at this standard, which was something that was published through the British Standards Institute a few years ago, but grew out of some work in the local government sector. Now it's called the smart city concept model because I think, well, I don't know, smart cities were a bit of a buzzword at the time, maybe still, but actually it's really suitable to any organization that is involved in planning activities to meet an objective. So it's it's a very generic model actually. And so what we're thinking of with things like the, say, river basin management plans is to, which already have their own specific data model in the systems that we work with, is to make relationships of those area specific data models to this more generic one. And by doing that in several different areas, we might be able to pull things together. So that's the data model aspect. I'm not going to say much about formats because I think it's the least important of those things I've identified. But I do want to say something specifically about geographical and geospatial data, because I guess in many areas, but certainly in environmental work, it's all about where something is, and looking at different information about a place that may have come from very different areas of work is of importance. And so this is just a screenshot of QGIS, and a lot of people have done some work with GIS systems. And this particular thing is showing a little patch of the River Test near Southampton. And we've drawn on it the Ordnance Survey water network and a selection of monitoring sites, where the blue ones were sites for measuring water quality and the red ones were invertebrate sampling. And the reason that we were looking into this was to investigate ways that we might use the Ordnance Survey water network as a set of linked data identifiers for small set stretches of river. So the GIS approach to analysing spatial data is obviously very powerful, and it's very widely used in the environmental sector. But it's really good for some things, but it's quite kind of geared up around this. You put it on a map and have a look at it, and of course, use some of the spatial analysis functions that come with GIS systems to work out what's inside what's near what, all that kind of thing. But there's also a whole load of data that we have about some of the things that are features on that map. So say the whole history of measurements at one of those monitoring sites, or some detailed information about the characteristics of each stretch of this river. And we want to be able to use the identifiers that come with these little river reaches to pull together information from lots of different sources. So that's one of the things that we're looking at. And again, another bit of standards work was this document that again was an OGC W3C collaboration on tried to get the world of GIS experts and the world of web data experts to understand each other better and make connections between the two approaches that can somehow bring the strengths of each together. And that's something that we try to build on in this work, and again is quite an interesting read if you're working in that kind of sector. So finally, I'll just say a little bit about, if you think this is the kind of thing that could be of some use in your area of work, what do you actually do to get started? So one thing that might be of use is, well, of course, there's loads of stuff on the web, but we've produced some a set of quite introductory articles for the DEFRA Data Services platform on this that are available through their forum. So there's a link there, and again, we'll share that later. So it's worth a read if you just want some introductory information about all this stuff. But I would say that in terms of practical steps, if you want to do something, is to start thinking about those standards for identifiers, data models, and formats, and think about identifiers first. That if you're responsible for managing data about some useful set of resources, both think about how you will refer to those things and how that set of identifiers might evolve in future, and try to find ways to make those available to other people. It could be simply just put them all in a spreadsheet and put it on your website or on GitHub or something. Or you can start looking into linked data standards. But I think the key thing is to think about definitive identifiers for your entities of interest and how you share those. And certainly have a look at existing data models that other people have used for the same kind of thing. So I'll stop there. It was a bit of I guess, a rapid summary of quite a lot of work, but I hope that gives some kind of picture of the things that we're doing and what it's for. Thanks very much for listening, and I'll hand back to Jack.
Thanks very much, Bill, for that fascinating talk. Yes, just to say, this is the opportunity where when the audience gets to ask any questions they have. So just a reminder to use the Q&A function in Zoom to ask those questions. I think some key points I'm going to take away from this is sort of treating data as infrastructure. And I think the analogy with roads was very apt. Sort of planning for the future in terms of data is crucial to collecting useful data. Yeah, also, perhaps we need to work a bit harder at sort of maintaining standards of data and reinforcing them, such as the identifiers, data models, and formats that you mentioned. So while we wait for any more questions to come in, we've got a couple there. I don't know how your knowledge of the international data, but if we compared to similar countries, how would you rate access to government or environmental data in the UK?
Yeah, I don't have an encyclopedic overview of what everyone's doing. I mean, I think the UK has done pretty well on this, and partly I think from there's a government initiative made about 10 years ago to set up data.gov.uk and to create a very large number of openly licensed data sets, and to I guess kind of in principle to make government data open where possible. And so there are now, I don't know, tens of thousands of data sets in data.gov.uk, and the Environment Agency and DEFRA were very active in doing that at the time. I think there's, that's mostly a success story. I think inevitably, like any of these things, it's a bit of a mixed bag, because some things are better maintained and more up to date than others, and some things were just kind of lobbed over the fence and ignored ever since. And the fact that there are so many things in there can make it quite hard to find the thing that you want. So in all of this, I didn't go into it much, but effective discovery and search of data sets. And once you find it, knowing is this the one that's actually relevant for you, and what do all the terms the use in it mean, and all that kind of thing is part of the picture. I guess a weakness of UK open data has been some of the spatial stuff. I think that's certainly improving, and the Geospatial Commission is trying to do things on that. But I think the funding model of the ONS survey has been a bugbear over the years, that quite understandably the way that they get the money has meant that they have to keep control of data that they produce, but there are certain things around that are very valuable for other people that have been slow to be forthcoming, like say a national address database or something like that. Although overall, I mean, the Ordnance Survey's been a big contributor to open data, but I think that's something where other countries do better. Certainly, I've seen some very strong work from the Netherlands and from New Zealand in spatial data and environmental data. So making it open and making it accessible and useful. So I think there's some great examples that we could learn from that other countries do as well.
Yeah. No, that's really interesting, and you're right, as you say. So it's sort of sometimes a moment of intense frustration when you know there's some data there that you need access to, but you just can't get it because it's controlled by the Ordnance Survey. But as you say, I think they are perhaps making progress towards reducing that issue with the sort of availability of LiDAR in recent years, which has been hugely beneficial. And also, I think Mastermap might be on the way soon. Might be made free. So we've got a couple of questions coming in. First is from Nikki Roach. Any thoughts on the use of social data sets through the Twitter API, for example, and how widely they're being or can be used?
Yeah, that's a good question. I don't really know, to be honest, in the sense that I haven't done any systematic work on it, but I know that there are people in the data science community that are doing some systematic analysis of social media, especially where things are sometimes georeferenced, and if people have comments of things that are happening at a place at a time, then you can gather a lot of information, or especially if there's photographs that have the kind of time and place metadata in them. I'm not quite sure what the licensing question is around things that come from Twitter. It's probably complicated, and and certainly there are data privacy and then kind of, if you like, sort of ethical considerations that come into that kind of thing. But yes, I think that it's a huge set of machine readable information that holds a lot of data in it. So I think you need some quite clever data analysis techniques to pull meaningful things out of it. But yeah, I don't have personal experience, but I think it's a great idea.
Yes, I think obviously Twitter is a huge mine of all sorts of information, and perhaps I think obviously as Twitter has become more widely used over the past few years, especially sort of around sort of very large events, especially things like events of disorder and things like that. And just over time, if there's any sort of analysis on sort of a ratio of genuine information to misinformation and that kind of thing, it's very powerful to really get a sample. But of course, there's many caveats to that sort of data, and how reliable and how accurate it is. It's lots of intensive work, I think, is needed on both the collection and verification of that sort of data. So it's it's very interesting aspect, the social data. We have another question here from Adrian Kelland. When data is shared or published, who should take on the risk of error in the data when used for purposes other than that it was originally collected for?
I guess it must be the person that uses it. It's going to be a kind of caveat emptor situation, I think. I think there's a responsibility of the data publisher to follow good practice, and that involves things like trying to document what your data means and providing information on methodology and how terms are defined. So to do your best to make it understandable, if people understand what it is and where it came from, then they can make an informed assessment of whether it suits them. But I think it must always be the person who's using the data that has to decide themselves if it's appropriate or not. And I guess that's one of the current weaknesses of some of the things that are in data.gov.uk, is that some of them are very good, but other ones are minimally documented CSV files where you have to try and guess what the column headers mean. and that's not in itself enough to be confident in it. But I think while there are always going to be situations where you're doing something that's important enough that you need to be really certain on how it's collected, nonetheless, the potential benefits of being able to reuse useful things that were done elsewhere means that I think we should be looking to try and enable that reuse of data. But I guess it's a kind of two-way street, that the person sharing it should take the steps to make it understandable, and the person using it needs to make an informed assessment of whether it's right for them or not.
Mm. Yes, I suppose if that data is then when going on to be presented to anyone else, if that whoever is consuming that data eventually, I suppose it emphasizes the importance of data attribution. So if needed, or if the user has any sort of concerns or questions about the data, they can go back to the original source and verify perhaps exactly why it might have been published, or any other circumstances regarding that.
Yeah, and I think that's kind of quite a bit of what's behind those FAIR principles that we were talking about, that when they're talking about scientific research, that is now ever more backed up by computational analysis or modeling of data, is that you've got to show you're working and cite your sources of data as well as just other people's academic work. So it's that kind of try to make it possible for other people to reproduce your analysis and decide themselves if they think you've done it right or not.
Yeah, that's the final one from me, really. It's because there's quite a few sample apps already on the DEFRA Data Services platform. I suppose, do you think perhaps that given the data available that we have now, should government agencies perhaps be a bit more proactive in sort of sending out asks to the community for making use of data, or making additional applications for data? Maybe they want the data interpreted in such a way, or not?
Yeah, I don't know. I mean, I think they could certainly be more active in general about some of the communication around this, because there's a lot of useful work going on, and sometimes people are not aware of it. So I think there are steps that could be taken quite simply to make more information available, but also in a world where there's so much information available and so much going on, you've kind of got to sell it to people to at some level to get people interested, and try to build communities around it and that kind of thing.
Yeah.
I think when it comes to things like applications or analysis, then sometimes there are things that make sense for the data owning organization to do, but often in that kind of value chain thing I was talking about, it may come down to others who have a particular responsibility or interest to pull out some kind of analysis to do that themselves. So, but the aim of linking things up is to make that easier and more possible. But there will always be a role for the data supplier to supply the data well, and a role for a data consumer to do their own thing for their own purpose. Yeah.
You touched on communities there, and I think it's very important that we try and set those up so technical and non-technical users sort of have this space to discuss data and ask questions about it and how it might be used. I think that's essential. So I think that seems to be all the questions we have. So that just leaves me to say thank you once again, Bill, for your talk. Thank you to Barbara from SciWem for helping to organise and run this webinar, and thanks very much to all of you for joining today. So I hope you enjoy the rest of your day, and goodbye.